Hello everyone, so in this video, I'll discuss the summary highlights of what we have learned about infinite series. So we found from our discussion that the test for convergence or divergence of the infinite series lies on the types of series. Okay, the table below is the summary of tests for convergence and divergence of the given series. So the first test is called the Term Divergence test. So in this test, you can use this for series of this form, summation of a sub n, where n is from 1 to infinity. That if the limits of a sub n is not equal to 0 as n approaches infinity, then we can say that the series diverge. Take note that this test cannot be used to show convergence. Okay, the second type of series is called the geometric series test. So in this test, the series should be of this form, summation of ar to the n, where n is from 0 to infinity. That if the absolute value of r is less than 1, then we can say that the series converge. But if the absolute value of r is greater than or equal to 1, then we can say that the series diverge. So the value of convergence, which is denoted by S, can be obtained using this formula. You have A over 1 minus R. Okay, the next type of test is called the telescoping series test. So in this test, the series should be of this form, summation of b sub n minus b sub n plus 1, where n is from 1 to infinity. That if the limits of b sub n as n approaches infinity is equal to L, then we can say that the series converge. And the value of convergence can be easily obtained by subtracting b sub 1 with L. So you have b sub 1 minus L. Okay, next type of test is called the p-series test. So in p-series, the series is of the form summation of 1 over n raised to p, where n is from 1 to infinity. That if the value of p is greater than 1, then the series converge. But if the value of p is greater than 0 but less than or equal to 1, then the series diverge. Okay, another test is called the alternating series test. So in this test, the series should be of this form, summation of negative 1 quantity raised to n minus 1 times a sub n, where n is from 1 to infinity. And in this test, if there must be two conditions that must be satisfied. Okay, the first one is that the terms of the alternating series must be decreasing. That is, a sub n plus 1 is less than or equal to a sub n for all n. And second, the limits of a sub n as n approaches infinity should be equal to 0. Okay, another test that you can use is the integral test. So take note that to use this test, the function f should be continuous, positive, and decreasing. So in this test, given the summation of a sub n, where n is from 1 to infinity. So you have to check whether the function f of n, which is obtained from the n term, which is a sub n, must be greater than or equal to 0, and f should be continuous, positive, and decreasing. So to test for convergence of this series, now we have to evaluate the integral of f of x dx, where x is from 1 to infinity. If the integral exists, then we can say that the given series converge. If the integral of f of x dx does not exist, where x is from 1 to infinity, then we can say that the series diverge. Okay, the next test is called the root test. So in root test, given the summation of a sub n, where n is from 1 to infinity. So we have to evaluate the limits of the nth root of the absolute value of a sub n as n approaches infinity, and you have to check whether this is less than 1. If the limits is less than 1, then we can say that the given series converge. On the other hand, if the limits of the nth root of absolute value of a sub n as n approaches infinity is greater than 1 or infinity, then we can say that the series diverge. But if the limits is equal to 1, then we can say that the test is inconclusive. Okay, the next test is called the ratio test. In ratio test, given the summation of a sub n, where n is from 1 to infinity. And if the limits of the absolute value of the quotient between a sub n plus 1 and a sub n, as n approaches infinity is less than 1, then we can say that this series is convergent. On the other hand, if the limits of the absolute value of a sub n plus 1 over a sub n as n approaches infinity is greater than 1 or equal to infinity, then we can say that the series diverge. And the test is inconclusive if the limits of the absolute value of a sub n plus 1 over a sub n as n approaches infinity is equal to 1. Okay, the next test is called the direct comparison test. So in this test, given the summation of a sub n, where n is from 1 to infinity. So we have to check whether b sub n is greater than or equal to a sub n, where a sub n is greater than 0. So this indicates that this is bigger, b sub n is bigger than a sub n. And if the summation of b sub n as n approaches infinity converge, then we can say that the given series also converge. Because from the definition, if the bigger series converge, then so does the smaller series. On the other hand, if b sub n is less than or equal to a sub n and b sub n is greater than 0, and the summation of b sub n, where n is from 1 to infinity, diverge, then we can therefore conclude that this series diverge. Because by definition, if the smaller series diverge, then so does the bigger series. Okay, the next test is called the limit comparison test. So in this test, given the summation of a sub n, where n is from 1 to infinity, we have to evaluate the limits of the quotient between a sub n and b sub n. If the quotient is equal to L and positive, and the summation of b sub n converge, where n is from 1 to infinity, then we can say that this given series also converge. On the other hand, if the limits of a sub n over b sub n as n approaches infinity is equal to L, where L is positive and summation of b sub n diverge as n starts from 1 to infinity, then we can say that the given series diverge. So from this table, then you can easily identify the test that is appropriate for the given series. For Module 1 grade computation, I would like to remind everyone that the computation of Module 1 is based on the following assessments. We have Diagnostic Exam or DE, we have Problem Set 1, Homework 1, and Long Exam 1. The corresponding weight for Diagnostic Exam is 10%, PS1 is 30%, Homework 1 30%, and Long Exam 30%, so total of 100%. The passing grade for this module is 70%. So if your computer grade, for example, is 87.75, and because that grade falls within this range, 86 to 89.99, so your corresponding module grade is 1.75. So that's the end of Module 2. I hope that you learn a lot from this module. See you guys in the next module.